Greetings of the day. I am Dr. K. Raghu Mohan Reddy, Associate Professor, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. The course name is Computer Aided Engineering. Today's topic is components of graphics database and database operations. Okay, come to the course learning outcomes. Students will be able to 1. Explain components of graphics database. 2. Classify the database operations in geometric modeling. Okay, by the end of this topic, students will be able to explain components of graphics database, classify the database operations in geometric modeling. Okay, right. Components of graphics database. A graphics modeling database typically includes the following major components. Okay, geometric data, topological data, attribute data, transformational data, and non-geometric data. Okay, so first and last one are geometric and non-geometric. Okay, let us see one by one all these things. Okay, so first one, geometric data. So geometric data defines the shape and size of the model using points, lines, arcs, circles, splines, B-splines, Bezier curves, surfaces, solids, and meshes. Okay, so geometric data defines the shape and size. Okay, the shape may be circular, okay, or rectangular, or triangular. Okay, so that it will be developed by points, lines, arcs, and circles. Okay, suppose if we use splines, B-splines, Bezier curves, we can develop some sort of complex surfaces. Okay, and if it is the combination of some solids and meshes, then we have to go with surfaces, solids, and meshes. Okay, meshes means a grid-like structure. Okay. Okay, right. That is about the geometric data. Now we'll discuss the topological data. Defines relationships among geometric entities such as adjacency of faces, connectivity of edges and vertices, boundary representation, that is BREP. Okay, topological data defines relationships among geometric entities. Okay, right. Next, attribute data. Third one. Attribute data includes color, texture, and transparency. Okay, material properties like density, reflectivity, layer or grouping information. Okay, that is about attribute data. Next, transformational data includes matrices for translation, rotation, scaling. Okay, translation, rotation, and scaling. So here the images of an object can be translated from one location to another location, or it can rotate from this position to this position, let us say. And scaling. Okay, we can scale down or scale up. Let us say this is the original one. We can scale down or we can scale up. Okay, so right, that is about the transformational data. Next, last one, non-geometric data. Okay, non-geometric data means tolerances, manufacturing features, assembly constraints. Okay, tolerance means here let us say the length of one side is 10. Okay, but usually we cannot make this dimension with exactly 10. Okay, so the manufacturer is having some freedom to make with 10 plus or minus some point, not 1. Okay, that is tolerance, means that it can be allowed for the purpose of using or at the time of assembly. Okay. Next, metadata, version, author, and timestamps. Okay. This is about non-geometric data. Okay. Next, database operations in graphics modeling. Okay. Database operations are critical for model creation, modification, and visualization. Okay. Now let us see what is creation. Defining new geometric entities. Okay. New geometric entities with points, lines, faces, solids. Okay. Next, storing attributes like material and color. Next, establishing parent, child, and topological links. Okay. That is about the creation. Okay. Next one, modification. Editing geometric parameters means dimensions, coordinates. Okay. So we can edit dimensions. Let us say the diameter of some circle is, let us say, 10 units. Okay. With this we can make one water bottle, let us say, base. Okay. So we can edit this diameter 10 with some 20. So obviously the entire part will be converted to the corresponding diameter. Okay. So this is nothing but editing dimensions. Okay. Editing geometric parameters. Next, updating transformation matrices. Okay, already we have discussed transformation means rotation, scaling, and translation. Okay, so we can update these dimensions too. Okay. Next, propagating changes through associative relationships. Okay, propagating changes through associative relationships. Already we have discussed that. What are the associative things? Let us say this edge is associative to this edge. So if there is any change in this edge, subsequently the corresponding change will occur in this edge too. Okay, that is propagating changes through associative things. Next, retrieval. Okay, querying specific entities or assemblies, accessing geometry for rendering or analysis, filtering data by attributes or features. Okay, querying specific entities or assemblies, accessing geometry for rendering or analysis, filtering data by attributes or features. Okay. Next, deletion. Removing unused or obsolete entities. Removing unused or obsolete entities. Maintaining referential integrity between entities. Okay, maintaining referential integrity between entities. Example, changing a cylinder's radius automatically updates all dependent holes and features due to associative database structure. Already I have this, I told that, let us say here one circle is there. Suppose if we update this circle, let us say with this seed circle, let us say we made, that means, let us say we copied some 4 more circles here. Suppose if there is any update in the dimension of this circle, automatically because of this associativity, all these 4 circles dimensions also will update. Okay, right. Next, advantages of efficient database design. Faster model access and modification. Okay, so we can access the model very fastly, and subsequent modification also will be very fast. Okay, better data integrity and consistency. Okay, so here the data may be modified or the data may be deleted, that it will be affected in the entire art or program, project. Okay, right. Reduced redundancy and errors. Okay, so here repeated things, let us say if the dimension is repeated, that the repeated dimension will be reduced and errors will be also minimized and eliminated. Okay, support for parametric and associative modeling. Okay, so here database design will be very effective in all these parametric and associated modeling. Next, seamless integration with PLM and ERP. Okay, right. Future trends. cloud and distributed database architectures for collaborative design. Okay, cloud and distributed database architectures for collaborative design. Right. Use of graph databases, example Neo4j, for handling topological relationships. Integration of AI and ML, artificial intelligence and machine learning, for feature recognition and design automation. So before I conclude, let me reiterate certain things. Let me summarize. Okay, geometric. Before we discuss geometric data, components of graphics database. So there are 5 different graphic database components are there: geometric data, topological data, attribute data, and transformational data, and non-geometric data. Of course, non-geometric data deals tolerances, etc. Because here this is non-geometric information. Okay, geometric data defines shape and size. Topological data defines relationships, and attribute data includes, it means attributes, color, texture, transparency. Next, transformational data includes matrices, that is transformations, etc. And non-geometric data, tolerances, manufacturing features, and assembly constraints. And database operations are creation, modification, and visualization. Okay, so model creation means nothing but building a model, that means image of an object with the CAD features, and subsequently we can edit or modify the earlier created features. And finally, analyze, or we can use for the retrieval. Next, deletion is one important feature, removing unused or obsolete entities. Next, advantages: faster model access and modification. Okay, better data integrity and consistency, reduced redundancy and errors, support for parametric and associative modeling, seamless integration with PLM and ERP systems. Okay, so finally the future trends. So here the cloud and artificial intelligence and machine learning are playing predominant role nowadays in all the fields. So here cloud and distributed database architectures for collaborative design playing a predominant role in the database design. Okay, so with this I'm concluding. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.